Imagine soil so fertile it's been growing crops continuously for over 2,000 years. Number fertilizer. No chemicals, no degradation. While your neighbor's garden dies after 3 seasons, this black earth in the Amazon rainforest keeps producing abundance, year after year, century after century. Scientists thought it was impossible. Big agriculture hoped you'd never hear about it. But buried beneath the jungle floor lies a technology so powerful, so simple, that it threatens a multi-billion-dollar industry, built on dependency. What you're about to discover will change everything you thought you knew about growing food. And by the end of this video, you'll know exactly how to recreate this ancient miracle in your own backyard. Deep in the Amazon basin, a blade slices through centuries of accumulated leaves. Most people expect to find the same pale, nutrient-starved clay that defines Amazonian soil, that characteristic reddish-yellow dirt that farmers abandon after just a few harvests. But what emerges instead stops archaeologists in their tracks. A ribbon of jet-black earth, sometimes running half a meter deep, stretches in every direction. This isn't topsoil. This isn't decomposed leaves. This is something else entirely, something that shouldn't exist here. The Amazon basin is notorious for having some of the worst agricultural soil on the planet. Despite supporting the world's largest rainforest, the ground beneath is acidic, depleted, and hostile to farming. Strip away the trees, and within 3 years, most fields become barren. The jungle's fertility is an illusion. All the nutrients are locked in the living biomass above ground, not in the soil below. Yet these black patches tell a different story. When scientists run their tests, the results defy explanation. Phosphorus levels are 70 times higher than the surrounding soil. Calcium levels are off the charts. The carbon content is stable, meaning it doesn't break down like normal organic matter. Even after experiencing T, carbon dating pushes the timeline back past the birth of Christ. This earth was engineered before Rome fell, before the Vikings sailed, before anyone in Europe knew the Americas existed. As satellite imagery improves and ground surveys expand, the true scale becomes visible. These aren't isolated garden plots. They're everywhere, scattered across millions of acres throughout the Amazon basin. Some patches stretch for several kilometers, forming a hidden network that traces the outlines of ancient settlements now swallowed by forest. Where the black earth ends, so does abundance. Modern farmers who attempt to cultivate the yellow clay watch their yields collapse within seasons. But within the boundaries of these dark zones, crops explode with life, requiring no commercial inputs whatsoever. Nobody alive today remembers making this soil. The knowledge died with its creators, but the evidence of their mastery remains, preserved in the very ground they walked on. In 1541, Spanish conquistador Francisco de Orellana became the first European to navigate the entire length of the Amazon River. His chronicler, a friar named Gaspar de Carvajal, documented what they witnessed. Sprawling villages connected by roads, cultivated fields stretching to the horizon, and populations so dense they seemed impossible for a rainforest environment. For over 4 centuries, scholars dismissed these accounts as exaggeration or outright fantasy. Later expeditions found nothing but endless jungle and silence. The consensus became clear. The Spanish had either lied or been deceived by jungle fever and desperation, but they were looking in the wrong place. The evidence wasn't hidden in stone temples, it was written into the soil itself. Starting in the 1990s, archaeologists began using satellite technology to map the Amazon in revolutionary ways. Instead of searching for ruins, they tracked chemical signatures and vegetation patterns. What they found rewrote history. The black earth wasn't random. It clustered along ancient waterways and formed precise geometric patterns, the footprints of planned communities. In some regions, these engineered soils cover up to 10% of all arable land, suggesting a population density that rivals many modern rural areas. Researcher Michael Heckenberger, working alongside the Quaker people in the Upper Xingu region, uncovered something extraordinary: a pre-Columbian urban network. Straight roads connected circular plazas. Defensive earthworks surrounded major settlements, and everywhere humans had lived, the soil was black, fertile, and deep. This wasn't wilderness. It was a managed landscape supporting thousands of people. The soil itself had become the monument, more enduring than any pyramid or palace. Analysis of the black earth layers reveals stratification, each adding to the depth and richness. Pottery fragments, animal bones, and food waste create an archaeological timeline stretching back millennia. Then, in the 16th and 17th centuries, disaster struck. European diseases, smallpox, measles, influenza, raced through indigenous trade networks faster than the colonizers themselves. Conservative estimates suggest that up to 90% of the native population died within a century of first contact. Entire societies collapsed almost overnight. Villages were abandoned, fields returned to jungle, and the intricate knowledge of soil building, passed down through countless generations, vanished with the people who held it. By the time European settlers arrived in force, they found what looked like untouched wilderness. The Black Earth remained, but its creators were gone. And with them, the secret of its making. A soil scientist holds a fragment of black earth between gloved fingers and places it under an electron microscope. What appears is nothing short of spectacular. The interior resembles a sprawling underground city, a honeycomb maze of interconnected tunnels, chambers, and passageways. A single gram of this substance contains between 200 and 500 square meters of internal surface area. That's the equivalent of a small studio apartment, compressed into something smaller than your fingernail. This is biochar, the foundation of the Black Earth's supernatural fertility. Biochar is not ash. Ash is what remains after organic matter burns completely in open air, a powdery residue with minimal structure. Biochar is different. It's created through pyrolysis, heating organic material in an environment with little to no oxygen. Under these conditions, the physical structure of plant cells is preserved, while volatile compounds are driven off. What emerges is almost pure carbon, arranged in structures that can persist in soil for thousands of years. Unlike compost, which decomposes within months, or chemical fertilizers that wash away with the first rain, biochar's carbon skeleton is extraordinarily stable. But stability alone doesn't explain the magic. The real power lies in the architecture. Those microscopic pores create an ideal habitat for soil microorganisms. Bacteria, fungi, and other beneficial microbes colonize the interior surfaces, protected from predators, drought, and the constant leaching action of tropical rainfall. Each chamber becomes a shelter where life can thrive. Think of it as building a coral reef in your soil. Just as coral provides structure for marine ecosystems, biochar provides scaffolding for the soil food web. Nitrogen-fixing bacteria establish colonies in the protected spaces. Mycorrhizal fungi extend their networks through the tunnels. The porous structure also acts as a sponge for both water and nutrients. The internal surfaces carry a negative electrical charge, attracting positively charged nutrients like calcium, magnesium, and potassium. These nutrients stick to the char instead of dissolving into groundwater, remaining available to plant roots for extended periods. Water behaves similarly. The char's micropores use capillary action to hold moisture long after the surrounding soil has dried out. During drought, plants can access this hidden reservoir. During heavy rain, the char prevents waterlogging by storing excess moisture. Perhaps most remarkably, biochar becomes more effective over time. As organic matter cycles through the soil, the char's pores gradually fill with nutrients and microbial colonies. Scientists call this aging or charging, and it's the reason ancient Amazonian Black Earth is more fertile today than when it was first created. This isn't just a soil amendment, it's permanent infrastructure, a foundation that continues working for centuries. Theory is one thing. Let's examine what happens when this ancient technology meets modern testing. A research plot is divided into 3 sections, each planted with identical tomato seedlings. The soil, water, and sunlight are the same. The only variable is what's been added to the ground. Plot 1 receives nothing, just native soil, a control baseline. Plot 2 gets standard commercial fertilizer, applied according to package instructions. Plot 3 is amended with biochar that's been charged with compost tea for 2 weeks before planting. Within weeks, the differences become visible. The control plot plants are thin and pale. The fertilized plants look better initially, greener stems, broader leaves, but problems emerge after the first heavy rain. Lower leaves yellow. The soil surface begins to crust. In the biochar plot, the plants are visibly larger. Stems are thick and sturdy, leaves are deep green and glossy. Root development is extensive. By harvest time, the numbers tell the complete story. The control plot yields approximately 2 kilograms of tomatoes per plant. The fertilized plot doubles that output to around 4 kilograms per plant, which seems impressive until you discover that only 50% of the applied nitrogen was actually used by the plants. The rest leached away. The biochar plot produces 8 to 16 kilograms per plant, 3 to 8 times the control yield, and twice the fertilized plot, A soil probe pushed into the control and fertilized plots encounters dry, compacted earth. Rain drains quickly, leaving the root zone desiccated within days. Most of the fertilizer has migrated below the root zone, inaccessible to plants. The same probe in the biochar plot pulls up moist, crumbly soil even after 2 weeks without watering. Nutrients remain concentrated in the root zone, held in place by the char's internal structure. Water content stays remarkably stable. This pattern repeats across crop types and climates. Corn, peppers, lettuce, beans. Everything responds to biochar with increased yields, improved drought tolerance, and reduced disease pressure. In some trials, water requirements drop by 3050%. The implications are staggering. Chemical fertilizers offer a temporary boost, followed by inevitable decline. They must be reapplied constantly. Biochar improves soil permanently. So if this technology is so effective, why isn't every farmer using it? The answer is a story of catastrophe, misunderstanding, and calculated economics. When European diseases swept through the Americas in the 1500s and 1600s, they destroyed more than lives. They destroyed knowledge. Up to 90% of the indigenous population died, taking with them centuries of accumulated wisdom. The Black Earth remained, but the methods for creating it vanished. No written records existed. The few Europeans who arrived afterward saw only jungle and assumed the land had always been wild. As industrial agriculture emerged in the 19th and 20th centuries, a new paradigm took hold. Fritz Haber's invention of synthetic nitrogen fertilizer in 1909 seemed like a miracle. Humanity could now manufacture fertility from air and natural gas. Agriculture didn't need complex soil ecosystems anymore. It just needed chemistry. Agricultural extension services spread a simple message. Modern farming means modern inputs. Bags of NPK became the solution to every soil problem. And crucially, these solutions required annual repurchase. A more insidious problem emerged: the demonization of fire in agriculture. Environmental campaigns correctly warned against uncontrolled burning of crop residues, which destroys nitrogen and creates air pollution. But these warnings made no distinction between complete combustion and controlled pyrolysis. Extension agents began teaching that all burning was destructive. The ancient practice of converting waste biomass into permanent soil fertility disappeared. An entire generation of farmers grew up believing that fire had no place in agriculture. Meanwhile, the chemical fertilizer industry thrived. Annual applications became the norm because nutrients didn't stay in the soil. Without the biochar matrix to hold them in place, nitrogen volatilized, phosphorus became unavailable, and potassium leached into groundwater. The system created a perfect revenue model. Guaranteed obsolescence. Every storm was another sale opportunity. Farmers weren't buying soil fertility. They were renting it, year after year. The Black Earth of the Amazon represented something dangerous to this model. Application rates vary, but 10% by volume is a good target, roughly 1 part biochar to 10 parts soil. Unlike fertilizer, biochar doesn't need annual reapplication. It becomes permanent soil structure. Even a single treatment produces measurable benefits for years. Maintenance continue adding organic matter, compost, mulch, crop residues, as you normally would. The biochar captures and stores nutrients from these additions, creating a flywheel effect. Water requirements typically drop after the first season. Disease pressure often decreases. Yields increase without additional inputs. We stand at a crossroads. On one side is the path we've been following: industrial agriculture built on annual inputs, degrading soil, and perpetual dependency. Global topsoil is disappearing. Some estimates suggest we have fewer than 60 harvests left if current practices continue. Chemical fertilizer runoff creates oceanic dead zones, greenhouse gas emissions accelerate climate change, and farmers worldwide are trapped in debt cycles. On the other side is a technology proven over millennia, capable of building permanent fertility while sequestering carbon, improving water retention, and reducing dependency on external inputs. The ancient Amazonians supported sophisticated civilizations in one of Earth's most challenging agricultural environments. They did it without fossil fuels, without industrial chemistry, and without degrading their resource base. 2,000 years later, their soil still outperforms modern agriculture. This isn't nostalgia for a primitive past. It's recognition that they solved a problem we're still struggling with. They discovered that abundance isn't something you extract from the earth, it's something you build into it. The choice isn't just for farmers. Home gardeners, permaculturists, urban growers, Anyone working with soil can apply these principles. Every handful of biochar added to your garden is a small act of rebellion against a system that profits from scarcity. The technology exists. The evidence is overwhelming. The only question is whether we have the wisdom to reclaim what was lost. The black earth of the Amazon is more than an archaeological curiosity. It's a message from the past about our future. It proves that soil fertility doesn't have to be extraction and decline. It can be built, sustained, and improved across generations. Modern agriculture has given us abundance through chemistry, but it's abundance on loan, paid for with degraded land and dependency. The ancient engineers of the Amazon offer a different model: abundance through infrastructure, built once and maintained through natural cycles. You now know their secret. You understand the science behind the char, the evidence from the field, and the practical steps to recreate this soil. The question is, what will you do with this knowledge? Will you continue renting your harvests from a bag, or will you invest in building soil that works for you, compounding its fertility year after year? The earth remembers what we've forgotten, but memory isn't enough. We have to act. Start small. Make a batch of char, charge it with nutrients, add it to your garden and watch what happens. Because ultimately, this isn't just about better tomatoes or higher yields. It's about remembering that we're not separate from the soil, we're part of it. When we build soil, we build future abundance. When we degrade it, we borrow from generations not yet born. The Amazonians left us their library, written in carbon and earth. It's time we learn to read it. The soil is waiting. What will you build?